Right, guys, chapter 10, using the Earth's resources. So this is just going to be a short lesson based just off of this specification point here. So using the Earth's resources for sustainable development. As you can see, the main thing you need to be able to do is distinguish between finite and renewable resources by being given information. Give examples of natural products that are supplemented or replaced by agriculture and synthetic products. So this is just general information provided by the syllabus, and it is reflected in the notes. So humans use the Earth's resources for warmth, shelter, food, transport, everything. We have to use the Earth's resources, that's where we live. Now, natural resources come from farming, agriculture, timber and wood, clothing and fuels, like crude oil. Finite resources from the Earth, oceans and atmosphere, are processed to provide energy and materials. And the chemist or chemistry plays a very important role in this to make new products and make things more sustainable. Now, the word sustainable means that you're meeting the current demands of the generation without compromising future generations. That's what sustainable means, and I'll come back onto it. So let's have a look at the notes. So finite and renewable resources. This just mentions, again, as the syllabus said, what we use the Earth's resources for. And here we have some examples. So water from the ocean can be used for drinking and for energy. Crude oil can be used for fuel. Forests can be used for wood, timber, rubber, cotton, all sorts. Rocks can be used for constructions and shelters. Minerals are used to make jewelry, glass, cans, ceramics. The soil is obviously for agriculture, and the animals are for food and wool, and for recreation, such as dogs. So how to classify finite and renewable resources? So the word finite is the same as non-renewable. So that essentially means that you cannot replace it within a suitable time frame. So for example, if you say crude oil, well, crude oil forms over millions of years. So if you were to try and argue that crude oil is renewable, the reason you'll be wrong is that the crude oil will not be replaced for future generations because it takes millions of years. So it will be non-renewable or finite. Whereas on the other hand, paper, it comes from trees, that is renewable because you can plant a tree, and within a reasonable time scale, that tree will grow and can be used again for the future generations. So here you will see a table of examples of finite and non-finite, or not, so examples of renewable resources, example of finite. So finite is a non-renewable. So here you have coal, crude oil, methane, limestone, and metal ores from the ground. And here we have solar from the sun, wind, wood, biomass, and sugar. So renewables defined as resources that can be replaced at the same rate at which they're used up. A finite resource are those that are being used up faster than they can be replaced, e.g. crude oil. And the problem is it will run out. Lastly, if we just look at sustainability, so students should be able to extract and interpret information about resources from chart graphs and tables. So this is just common sense. Use orders of magnitude to evaluate the significance of data, which basically means be able to divide, say, this one pollutes 10 times more than this one. So just looking at the data mathematically. Let's just look at sustainability as the final bit. So why is everyone looking to be more sustainable? Well, in order to be more sustainable, they're trying to conserve finite resources so they don't spoil it for future generations. That's why they're going towards these renewable resources. I've already defined sustainability for you. So meeting current demands without endangering future generations from meeting their demands. Here's an example. So if you're making a plastic, it comes from crude oil, from fractional distillation. Then once you get your alkane, you crack it to turn it into an alkene. Then you take your alkene and you polymerize it to turn it into a polymer. So there's a lot of stages involved. So plastic is not good. Describe the process of cracking. That's just revising from organic chemistry. You vaporize your sample and you pass over either a hot catalyst for catalytic cracking or over steam for steam cracking. Again, this is just revision of the organics. So test for unsaturation with bromine water, going orange to colorless. And here it's showing you in industry how to make ethanol. So again, revision from the organic course. So you take your alkene, you apply steam at 300 degrees. The pressure is raised to 60 times the atmosphere, and use a phosphoric acid catalyst. So it's a highly energy process. However, the good thing is it produces a very pure product compared to fermentation. Anyway, that's more organic than sustainability. So this just talks about fermentation. It's using this example, the notes, just to show you that here is a renewable resource used to make ethanol. Here's a non-renewable resource, or finite. And the key thing for you to recognize is they each have their pros and cons. So while this one requires high energy demands, which could mean fossil fuels are being burnt a lot, this one produces a pure product, whereas this one produces an impure product. So then you will need extra steps in energy to purify this by distillation. So there's a lot of complications. So in answering these questions, a lot of the time you have to reach a conclusion and you have to decide which one's better. There's no right or wrong answer. As a final example, we've got some wood chips here used instead of fossil fuels to power up a station. So while you could argue that wood chips are renewable, unlike fossil fuels, the problem is that you're going to have to transport your wood chips. You're going to have to cut a load of trees down, ruin a lot of animal habitats, prevent a lot of photosynthesis, and so on. So there's many complications involved. This will be looked at later on in chapter 10 when we look at the life cycle assessments. So that's the end of this lesson. And the next lesson, we're going to be looking at something more proper chemistry by looking at potable water and how you make water safe to drink. See you next time.